Hello everyone, how are you doing? Good. Have you been enjoying yourself so far today? Yes. Are you tired? Is your brain full? No? You got a little bit more left in here? We want to talk about HTML5 video today. Usha's told me that I can speak until, like 22:30 this evening, so is that all right? Will you stay with me all that time? No? No? Okay. All right. Well, let's discuss HTML5 video. I gave an opening keynote this morning telling you that Thirsty Head is my company. I've spent a lot of time doing web development, but I've been doing HTML5 development most recently. And I've been spending a lot of time at Time Warner Cable, a cable TV company. And what we are doing is turning around and allowing you to watch live TV and watch video on demand and watch recorded DVR content, not just on your TV, but on your smartphones and tablets and so on and so forth. And even when you're watching video on the TV, many times that involves the HTML5 video tag. So a lot of what I want to talk to you about this afternoon are the various ways we can do to make sure that you can get video available to you through that tag. Because video really is everywhere these days. It's amazing to me how pervasive it's become. I have a 10-year-old son, and he loves nothing more than playing computer games. He would play it all day long if we'd have let him play those things. So what we say is, Christopher, you must stop playing video games. He says, okay, Dad. And then he goes on to YouTube and watches other people play computer games. He's a very smart son. He makes me very proud when he does things like that. Yeah? Yeah. It's also interesting because I have a 6-year-old daughter, and she has gotten to be very selfish. She is not interested in waiting for her favorite TV show to come on. When she wants to watch Dora the Explorer, she wants to watch it right now. And things like Netflix have allowed her to be selfish like that. Now, what am I doing? I am talking about HTML5 video and how kids today have a very different set of expectations. The reason why I'm lingering on this Netflix screen a little bit longer is because I like saying, I'm the man of the house. I rule the roost. Except when anyone wants something. I could be sitting in the family room watching a Netflix video on my TV. And then my daughter comes in and she says, Daddy, I'd like to watch Dora. And because she's cute, I say, okay. And I pause Netflix, flip it over to Dora, she begins watching. I pull out my laptop and hit resume. And that happens until my son walks in the room and says, Dad, I'd like to play a video game. I say, okay, because he's cute. I pat him on the head. I pause my Netflix video, give him the laptop. I reach for my iPad, hit resume, until my wife walks into the room. She says, I'd like to read People magazine right now. I said, you get it in paper. She says, I like it much better on the iPad. So once again, I hit pause, hand her the iPad, and pull out my iPhone and hit resume. You think I'm making up that story. That is the story of my life. Every day. Every day. But think about what we've just described. Being able to start a movie on my TV and move to my laptop and move to my tablet and move to my iPhone. That is the expectation we have now as consumers. We're all selfish. We expect not only our websites to flow like water through all these devices, we expect things like video to be available to us on any device that we have. So a lot of what I want to talk about are ways we can do that. And I'm a published author. I've got half a dozen books under my belt, and I'm not going to stop writing books, excuse me. But this is a project I've been working on for the past year or so. It's called pixeltarget.com. It's live right now, pixeltarget.com. And the reason I'm mentioning this to you is because I run the HTML5 Denver user group. And before that, I ran the Boulder Java user group. And before that, I ran the Denver Java user group. For 10 years, I've been running user groups in the Denver area. And for 10 years, people have asked me, can you please videotape the meetings? And I've always said no. Until last year. Until last year, I did start videotaping these presentations. And so if you go to pixeltarget.com right now, you will be able to turn around and start watching videos. I mentioned CouchDB earlier today. And so if we come in here, buffering. This is HTML5 video as well. And so if you want to learn more about this, the best thing to do is start using the technology. Start getting excited about it and figure out all the different ways you can manage these things. So between YouTube and Netflix, and yes, even Pixel Target, we find that HTML5 video is truly pervasive. So what I want to do is I want to show you how you can begin implementing these things as well. And so what we're going to talk about are three basic things. We're going to talk about the HTML5 video tag, but we're going to get that out of the way early because I assure you it is the least interesting part of this presentation. But we do need to discuss it, and it is a very impressive tag. But where you're going to be spending most of your time is not putting the video tag into your web page. It's like dealing with things like codecs and containers. Containers and codecs. How many of you understand the difference between an MPEG-4 container and an Ogg container and a WMV container? How many of you understand the difference between an H.265 codec and WebM codecs and things like that? So that's what I want to spend a lot of time discussing. The technical details of how to get your video on the web. And where we'll end up is talking about the future of video streaming. So we have a lot of material to cover in a very short amount of time. Shall we begin? Yes. All right. So what I have here is not an example of HTML5 video. What I have here is actually an animated GIF. And I start with this because it allows us to talk about some of the basics. Notice that one of the things we see here is that this is 36 frames running in just under a second. And so if we come over here, have I shut it down? Oh, unfortunate. All right. If we come over here and take a look, there we go. If we come over here and open this up in a viewer, we can see that in fact this is truly 36 frames that are all bundled up into a single file. Yeah? And the fact that it's looping over and over and over again is what gives us the illusion of motion. So even though animated GIFs have been around since the early 90s, they illustrate an important idea behind video. Is that it may be one file, but it's certainly multiple frames within that file giving us the illusion of motion. Does that make sense? Yeah? Excellent. Let's move on then. When it comes to video, it's hard not to discuss television. And this will give us an opportunity to discuss some more aspects of video as well. When we talk about standard definition TV, it's helpful putting some measurements on that. And standard def TV might be 720 by 480, but realistically, it's probably 640 by 480. Now that sounds an awful lot like VGA resolution, doesn't it? It sounds an awful lot like the resolution you'd get back in the 1990s. And in fact, it is. But being able to discuss standard def in terms of pixels really helps us figure out the size of these particular videos. Notice that when they're talking about refresh rates, once again, we start expressing it in terms of frames per second. High-def TV, as you might imagine, gives us a much larger space. It's higher resolution, which means it gives us more pixels. You might have heard of 720p or even 1080i or 1080p. Now, what they're referring to here are the vertical pixels. So often we are worried about the width of these things, but when it comes to television, they measure it in terms of vertical pixels. So when we talk about 720p versus 480p, we can see that standard definition gives us 480 lines of pixels. 720p almost doubles it. 1020 or 1080p, excuse me, more than doubles it. So we begin seeing we're increasing the pixel density. We also get to discuss interesting things like the P and the I. P is a progressive scan, which means it paints all 720 lines at once. 30 times a second, we're getting all 720 lines. When we talk about 1080i, it's interlaced, which means we get exactly half of those lines on the first pass and half of those lines on the second pass. So 1080i gives you the same number of lines, but it only paints half of them at a time. 1080p is the highest definition we have. It paints all 1,000 lines every clock tick. Does that make sense? Yeah, excellent. So we're building up a vocabulary now. We understand now that frames per second is important. We also understand the size of the image is important. And it helps you deconstruct things like this. These are the specs from the iPhone, the 4S, not the 5 that came out most recently. But when we see that the iPhone supports a 960 by 640 pixel resolution, we begin thinking, oh, how does that apply to standard def TV? How does that apply to high-def TV? The irony of the iPhone is that it can truly record videos at a higher resolution than it can play back. That's no small feat, is it? But understanding the basic dimensions of the video, how much data you're putting on the wire, certainly helps us. One more basic concept, and then I'll actually show you the video tag itself, and that's this notion of progressive downloads. Now, video files, if you have been dealing with video on the web for quite some time, you might remember in the bad old days, you needed to wait for the entire video to download in order for it to start playing. That's because the headers in video were traditionally written at the end of the file. When you were writing that file out on disk, you didn't know how big it was going to be. You didn't know all of those characteristics until you had written it out. So it made sense that you wrote all the video out and then put the headers at the back of the file. What that meant, though, is you had to wait for the entire file to download. In YouTube, you see that happening. You know that this bright red bar is where your current playhead is, but this faded red bar in there is how quickly that file is being downloaded. These can be very large files. These can be hundreds of megabytes, even gigabytes of that keynote presentation that I did this morning was over a gigabyte because of all the video in there. So can you imagine waiting for a gigabyte to download? No. What you want to do is move all those headers to the front of the file. So your player knows how long it is, it knows the frame rate, it knows the size of the video, it knows everything it needs to know in order to start playing it. And then it's a race, isn't it? If the playhead moves faster than the download speed, what do you get? The dreaded buffering, yeah? Yeah, but if it's downloading faster than you're playing, if those two are constantly chasing them, again, it's giving you the illusion that I am playing this file instantly, when in fact it's just being progressively downloaded. Yeah? Ah, good. So what does this have to do with HTML5? Absolutely nothing. other than you need to know all of these things in order to use the tag. I've said several times the tag is the least interesting part. We'll see it in just a moment. But in order to really utilize that tag, you need to understand what an MPEG-4 is. You need to understand how Flash and 264 and WebM and Ogg, all these things play in the HTML5 space. I want to give you a couple of resources to read up on this a little bit more. This is an outstanding book, HTML5 Up and Running by Mark Pilgrim. It was one of the first books on HTML5 out on the market, and I think it's one of the best. And the reason I'm recommending it to you is that the entire contents of this book are available on the web for free. If you go to dive into html5.info, dive into html5.info, you can read this entire book for free, including the chapter on HTML5 video, which I think is one of the best introductions that I've read yet. Now, if you want more than just a chapter, there is the definitive guide to HTML5 video, and the title is well descriptive of what's in the book. It truly is a greatly in-depth version of what this is. But most of the people are going to be happy enough with what Mark Pilgrim offers you up in one chapter. Yeah? Good. So let's begin. Let's talk about where this silly video tag is supported. Here's a hint. All modern browsers, which is really nice. IE 9 and above. Firefox, Safari, Chrome, Opera, iPhone 1, Android 2 support these kinds of things. So the video tag is absolutely ubiquitous. And what does that mean? If you see code like this, are you intimidated at all? No, of course not. You have an image with a source and width and height on it. This is how we've been displaying videos literally since Web 1.0. This is HTML5. Pretty boring, isn't it? But that's good. That's good. And that was the intent. They wanted to introduce a tag that was so familiar you wouldn't bat an eye. We're not here to talk about audio, but do you know what the audio tag looks like? Absolutely you do. You don't have a width and height on your audio, but other than that, you have an audio tag as well. Yeah? Now what's interesting about this is let's consider the image tag. There are at least 3 popular image formats we can use. What are they? What's one image format? GIF, absolutely. What's another one? JPEG. What's a third? PNG. Yes, absolutely. Does it bother you that there are 3 image formats on the web? It shouldn't. Because every browser on the planet can read every one of those file formats. That's not the case with video. It will be eventually, but unfortunately, there's not a single container codec combination that will work across all browsers. So while this is all you get for the image source, and in a simplified form, that's what you get on the video source as well. But in a more complex example, and one that's far more real world, you're going to open up that video tag and you're going to put individual source elements inside of it. And your browser is smart enough to start at the top of the list, and it says, I don't know that format, I'll try the next one. I don't know that one, I'll try the next one. It'll literally work its way down the list until it can find a video format that it can play, and if it can't, only then will it give up. So, right out of Mark Pilgrim's book, dive into html5.info, we see something that is pretty straightforward. Something that starts with MPEG, and then goes to WebM, and then Ogg, and then fails over to Flash. And if your browser can't play any of those things, we even have a paragraph in here that says, oh, if you want to download that video, try this or try this or try that. Now, it's easy to complain that, oh boy, I have to support video in different formats. Or it's easy to look at this and say, look, in a standard way, I have a way to play video in every browser on the planet. So you have to decide if your cup is half full or half empty at this point. As you can tell, I'm kind of an optimistic guy. I look at this and I say, wonderful. I have a way to serve up video to all browsers in a nice, standardized way. Yeah? Good. Well, let's talk about all those different sources then. Because that is where we get to the container codec story. These are the combination of files that we need to be well versed in. So, YouTube, when it first went live on the web, supported the Flash format. And that was a great choice on their part, because Flash is all but ubiquitous. Flash is loaded in 99.999999999% of all browsers. So it was a pretty safe bet. What browsers is Flash not going to run in? Rats, mobile phones, right? It's not going to run in iOS devices. It's not going to run on the iPhone. It's not going to run on iPads. And it never will. So in 2007, when the iPhone came out, YouTube had a hard decision to make. They either could say, nope, we're not going to be available to you on the iPhone, or they can support their videos in two different formats. And that's absolutely what they did. They transcoded all of that Flash video into an MPEG format that the iPhone would be able to play. And while it's not fun having to support two different versions. It's a business reality. And YouTube did that, and that's why you're able to watch videos on both your mobile devices and your desktop devices as well. So let's dig in a little bit, and let's figure out what containers are out there and who supports them, and then we can talk about what codecs are out there as well. The best way to understand a video container is to simply think of it as a zip file, or a tarball if you're familiar with Unix analog. What's interesting is a zip file can contain literally anything, can't it? What it's meant to do is take all of my source code, it might be hundreds of files, and store them in a single file. So if I needed to toss you my entire application, I wouldn't make you do 100 downloads, I'd make you do one download. Right? And it could be a zip file, it could be a tarball. If you're a Java developer, it could be a jar, or a war, or an ear. This is a very common pattern, isn't it? The other thing that zip files gave us were compression. Not only did they aggregate all of our data together, it compressed it so it was a quicker download. Now, in order to use that zip file, you needed to have something on the other end that would understand that container and be able to decompress it. While we've been talking about zip files and tarballs and jars and wars and ears, the same thing is going on with video containers. Except what those video containers do is they store multiple tracks. There's probably going to be at least one video track and at least one audio track. But there could be multiples of each. There could be multiple video tracks coming in at different camera angles. There could be multiple audio tracks, English, Spanish, Hindi, right? But the idea is this container will contain all of them. And it will also optionally compress them so it's a faster download. So if you understand zip files, you understand video containers now. And can you tell this is stolen directly from Mark Pilgrim and dive into HTML5? Again, it's a wonderful chapter to give you more information about what we're talking about here. So there are a lot of different containers out there, just like there's zips and tars and wars. In the video land, there's MPEG, there's QuickTime, there's Flash, and the list goes on and on. So what you have to realize is that many times you'll have to provide a zip file and a tarball download for people. So based on what operating system they're running on, based on what compression software they have preloaded, we'll be using the same metaphors right here. Let's talk about MPEG. Because MPEG is the most popular. If you are using MPEG, if you are watching cable TV, you're using the MPEG container. If you are watching Blu-ray and DVD, you're using the MPEG container. This is kind of the gold standard. Broadcast television, Blu-ray and DVD all use these. Now, it could either be MPEG 2, which is uncompressed, or it could be MPEG 4, which is compressed. But both of those containers are widely used. Now, we can also talk about QuickTime in the same conversation, because QuickTime MOV files started as an Apple proprietary format. And what Apple did is it turned around and threw it over the fence to a standards body, IETF. And when IETF standardized it, it created MPEG out of that. So movies, QuickTime movies, and MPEG files are virtually identical. So you'll find that it's very often able to read both of them simultaneously using the same engine. Now there's Flash as well. Flash is a container, FLV files. Obviously, you need to have the Flash plugin in order to do that. And we talked about this already, that the Flash runtime is ubiquitous for desktop browsers, but it's not available on mobile devices. And that wouldn't be a bad deal, except look who ran away from Flash first. It's really interesting, isn't it, how much of state-of-the-art is driven by pornography. Now, I wouldn't know because I never watch it myself, but I read about it. Yeah, I read about it quite a bit. And when the pornographers decided they were leaving Flash for HTML5, it really tells you something, doesn't it? Adobe now has said we're not going to support Flash on mobile devices either. Adobe is going towards an HTML5 solution. Microsoft has a format called Smooth Streaming or Silverlight. They've backed away from Silverlight, saying since that's not available on iOS devices and Android devices, we're going to be moving towards HTML5. So where the pornographers led us, Microsoft and Adobe were not far behind. There's another file format you might be familiar with, especially if you're a Linux fan. How many of you like Ogg? Yeah, a couple of you? Absolutely. Ogg is an open source container. Now, if you've been listening to music, you've been listening to Ogg Vorbis. And I'm getting a little bit ahead of myself, but that's a container and a codec. Ogg is the container, Vorbis is the codec for audio. Ogg Theora. Theora is the video codec. Ogg is the container. So we're beginning to see how these things all fit together. I mention WebM because Google is behind this. WebM is yet another container. And I don't want to get too bogged down in licensing issues, open source, and things like that. But while MPEG is the gold standard for network television and Blu-rays and DVDs, there is a patent involved with that. And so if you're a fan of open source, that gives you concern. Now, the patent is never going to apply to you as an end user. That is going to be free. But for a content creator, if they get above 100,000 users, that's when the licensing kicks in. And so Google has a vested interest in coming up with an open source alternative, because when they have something like YouTube that has Flash and MPEG, they don't want to get to the place where they have to start paying license fees on what's essentially a free service for them. And so they're developing WebM, which is supposed to offer you the quality of MPEG with the openness of Ogg. Does that make sense? Yes. Very good. So these are the containers. Now let's start talking about the codecs. So codec is a portmanteau. It's a combination of two words. It's short for compression, decompression. Because remember, with zip files, it compresses the files. Tarballs don't compress, but you normally gzip your tarballs. Tarballs are a container, gzip is a compression. And so there are many different compression algorithms out there for plain old files. There are many different codecs out there for video. So here are some of the popular codecs: H.264, Theora, VP8, and WMV. It's not enough to understand a container, and it's not enough to understand a codec. You need to understand both, because we can begin mixing and matching these things. For instance, H.264 is a codec that's traditionally associated with MPEG containers. Did you follow that? Good, you've been paying attention. Yeah. But H.264 as a codec can also be loaded up in an FLV file. So you can have Flash using H.264, and you can have MPEG using H.264. So understanding both sides of this story are very important. H.264 is what you normally get through MPEG. And so it's very common for you to say MPEG, oh, and just assume that H.264 comes along for the ride. Now, I want to talk about this for a little bit more, because you remember why we don't have Flash on iPhones? It's because Steve Jobs hated Adobe, right? That's how it might have played out if you didn't know the details. The core problem with Flash on mobile devices is Flash's codec is implemented in software, whereas most MPEG decoders are implemented in hardware. You have MPEG decoder chips in all your mobile phones. You have MPEG decoder chips in your Blu-ray player and your DVD player. You have MPEG decoder chips in your cable set-top box and your television itself. And when something is implemented in silicon versus software, it is orders of magnitude faster. And on mobile devices, it is orders of magnitude easier on your battery life. So Steve Jobs says, no Flash on my iOS devices, not because I hate Adobe, but because I would get 42 minutes of battery life out on this device. Whereas if you have MPEG video and it's handled in silicon on a chip, you can get 6 to 8 hours of video playback on an iOS device. So it's nice knowing the technical reasons behind these kinds of things. The reason why MPEG is ubiquitous is because it's implemented in silicon. The chips are literally a dime a dozen. And that means that it's fast to decompress that H.264, it's battery friendly, and ubiquitous. It's hard to argue with those. Now, Theora, I already mentioned, is the video codec. The problem with Theora is that it's an inferior codec. You don't get the high quality video playback that you get with H.264. So what you're faced with is an uncomfortable compromise. Either we can have the highest quality MPEG-2 H.264, that's patent encumbered, that's license encumbered, or you have a free alternative, Ogg and Theora, that is a vastly inferior video viewing experience. This is why WebM as a container and VP8 as a codec are so interesting. Just like H.264 and MPEG tend to track together, WebM and VP8 tend to track together. And when that gains a lot of industry acceptance, what we will have is an open source alternative, a non-patented alternative to MPEG and H.264. What Google is going to have to do, though, is it's going to have to start throwing WebM and VP8 on silicon and start baking that into all of the Android devices, all the smartphones and tablets and things. And only when we get the codec in silicon will we have a true apples-to-apples comparison. And you'll be able to compare it based on battery life and video quality and everything else. And I got to tell you, at the end of the day, if I have something that's equal and open source, I'm going to go with that as well. Yeah? Good. Good. So here's what we're faced with now. there is not a single container codec combination that will work across all browsers. So we are in this uncomfortable situation of having to know that, okay, Firefox only supports the open standards, WebM and Ogg. Safari, obviously, supports MPEG because it was based on QuickTime, which Apple has years of history with. So if we want a single video file format that plays across all browsers, we're not there yet. But being able to support multiple codecs and containers is not hard to do. And if you're transcoding video, there are transcoders out there that make it seamless to move from MPEG to Flash and from Flash to WebM and from WebM to Ogg and back and forth. There's an open source codec called FMPEG. FMPEG. And that knows how to speak all of these different codecs. Yeah? Good. Well, the last thing I want to talk about here is the future of video. And that's streaming. That's streaming. Because just as I said this morning, I want your websites to flow like water through all your different devices. I want your video to flow like water as well. And what that means, what we have to do, is get out of the mindset of having one big progressive download, one big gigabyte video file, and start thinking about ways to chop it up into tiny pieces and send down video quite literally 10 seconds at a time or 2 seconds at a time. And this implementation detail, moving from one big video file to segments of that video, is absolutely the future of video. You can't get away from it. As a matter of fact, if you want to have a video player in the Apple App Store and it plays video longer than 2 minutes, you are required to implement HTTP live streaming. You're required by Apple to implement a streaming solution. I'm pausing for dramatic effect. I mentioned Google Maps earlier. I worked on the Google Maps project not as a Google employee, but as a satellite imaging provider. These satellite images were enormous. I would end up creating 2,000 pixel thumbnails of these videos. People say, wait a second, 2,000 pixel thumbnails? Yeah, because these were 20,000 pixel images. But would we distribute that big image all at once? No, what we would do is we would tessellate it. We would tile it up. When you're looking at Google Maps, it's not one big image. It's 256 pixel by 256 pixel tiles that get downloaded. If you have a slow internet connection, you can actually see the individual tiles download until they form one big map. And that is exactly what I am talking about with video as well. And the reason it's so important to tessellate your video, just like it's important to tessellate your Google map, is because let's say I'm sitting indoors and I'm watching a YouTube video and it's progressively downloading onto my mobile phone on a Wi-Fi connection. And then I walk outside and my mobile phone flips from Wi-Fi to 3G. What happens to my video playback? Buffering, buffering, buffering. If, on the other hand, you're using video segmenting, you've lopped that hour-long video into 10-second segments, what's happening is your mobile device is constantly talking back and forth to the server. And it says, I'm on Wi-Fi, so send me down Wi-Fi of appropriate content. And then when I walk outside and get onto a 3G network, I have no more than 30 seconds of video cached up on my device. And so when my device tries to download the next 10 seconds, and it hasn't gotten there yet, it says, hold on, time out, time out. I don't have enough time to get the next 10 seconds. So I'm going to reduce the bandwidth and have you send me a lower resolution video version of that video. And it'll continue to scale down until you might only get audio out of that. But what your player is trying to do is provide a seamless video watching experience. So if I'm on Wi-Fi, I get Wi-Fi caliber content. When I flip over to 3G, I get 3G caliber content. But as an end user, I don't notice. It's seamless video playback. And then when I walk back inside, it can ramp back up again. This is literally not possible if you're using progressive download. Once you've started downloading that gigabyte file, you've committed to it. Yeah? So this idea of streaming, this video streaming like water, is incredibly important. And much like Apple created the QuickTime format and then threw it over the fence to IETF to standardize it, they did the same thing with streaming video. Apple's streaming format is called HTTP live streaming. And that's such a mouthful that most of the cool kids just say HLS. But HLS is Apple's proprietary format that they have thrown over the fence to IETF. And when it does get standardized, it'll come out the other end as MPEG-dash. But regardless of whether you use HLS or dash, or Adobe has a format called HDS, HTTP dynamic streaming. Microsoft has something called smooth streaming. All of the major video providers have a solution to this. Now, how they vary is how big the segments are. Apple defaults to 10-second segments. Microsoft defaults to 2-second segments. They're both tunable. You can decide what length you want your segment to be. But each segment is in a slightly different file format. And what's more disruptive is the manifest file that describes that is in an incompatible different format for Adobe, Microsoft, and Apple. So even though the interface is different, the idea, the ideology is the same. And so there isn't a player out there right now that supports MPEG-dash. It's coming soon. In the next year or so, we'll begin seeing MPEG-dash come out. I believe Google Chrome has some early support for it in their beta releases, nothing in their mainstream product. Google Chrome will probably be the first browser to support this. So it's interesting seeing all these different streaming solutions floating around out there. So now, in order to serve up video, we have one more thought process we have to go through. When I'm shooting video, I now need to decide what media encoder to use. I'm going to hypothetically put this in an MPEG container and use an H.264 codec. But then I have a media segmenter that takes that file and lops it up into its individual segments and writes out a manifest file so that player knows how to download those things. And the manifest file is what says, if you're on Wi-Fi bandwidth, start downloading these segments. If you're on 3G, start downloading these segments. And this is how the adaptive comes in. We understand the streaming, and now we understand the adaptive portion of it as well. So all this is going on under the covers. When you're playing video at pixeltarget.com, that's exactly what's going on. As a matter of fact, let's come in here and do a quick view source. I said a quick view source. Come on, you. Oh, no. All right, let's try another browser here real quickly. Come on, you can do it. Come on. Oh, the demo gods are very angry at me right now, aren't they? Let's try this one more time, and if it won't work, I'll move on here. All I wanted to show you, there we go, is not the video itself. Waiting. Here's what I wanted to show you is the source. Oh my goodness. I'm having the hardest time in the world showing this to you. All I wanted to show you in here, expanding this out until we can eventually get to the player. We can see what's going on. I have a video container in here with a width and a height associated with it. That video container has a source. One of them is a pointer to that HTTP live streaming. One of them is a source to Microsoft Smooth Streaming. And one of them is a source to Flash. So when you start looking at YouTube and Netflix and even Pixel Target, it's nice being able to go in and do a view source and see what's going on. And that's how, oops, let me zoom back out here. That's how Pixel Target should run across all of your devices. When you're on Google Chrome, it might be playing back in Flash. When you're on Safari, it might be playing back in HTTP live streaming. But in all cases, you're getting the video container codec that that particular browser understands. So to wrap up here, if you've been watching any of the Apple events, any of the Steve Jobs keynotes, or the Tim keynotes, or any of the product announcements, if you've been watching any of them since 2010, you've already been using HTTP live streaming. If you're using an iPad app that is serving up video from Netflix, from YouTube, from any of these places, you're already using HTTP live streaming. All of this technology is out there. And it's amazing that if you had just focused on the video tag, you would have missed all of the most interesting parts of that story. Yeah? Did you enjoy yourself? I did as well. Thank you so much.